Last thing I would like to talk about for this set of videos is sigma and pi bonds. Now remember that whenever you have the last topic for this set of videos is sigma and pi bonds. Now whenever a bond first occurs between an atom, the first bond that always occurs is a sigma bond. So a single bond between two atoms is always considered a sigma bond. And what a sigma bond is essentially direct overlap of two orbitals, half-filled orbitals in order to have a fully filled atomic orbitals. Remember, we get hybridization and all that, yada yada, but it's essentially a direct overlap. Well, once you have electrons here, the electrons, they don't like to share space with other electrons. You can have two electrons in the same orbital, but once you get that many, they're just like, we're done. We have no more space. So how do you get multiple bonds? Well, the way multiple bonds occurred is not a direct overlap, but you actually have electrons that are shown in, say, a p, in a p orbital, that are essentially aligned up in the molecule. So you have the nuclei here, you have the p orbitals, and if those p orbitals line up perfectly, you can get a pi bond to form. And the pi bond just allows electrons to essentially cross back and forth between the two different nuclei, and they essentially share that electron. So this is for a sigma bond. It's always the first bond that occurs. So we consider something with a single bond to have one sigma bond. If something has a single bond, or a double bond, it has one of these sigma bonds, but then since all this space is used up, the space directly between the nuclei, where the other second bond comes in is the pi bond, which is shown here. So that's the pi bond. When you go to a triple bond, you have one sigma bond and two pi bonds. Well, if all the space is used up above and below the nuclei, where does that other pi bond come from? It's actually a pi bond that occurs, that if you imagine this rotating 90 degrees along this axis, coming out and into the screen, that's where the other bond goes. That's the space that those electrons are filled in, and it allows those electrons to jump between the two different nuclei, creating a bond. So anything with a single bond has a sigma bond. If you have a double bond, you have one sigma bond and and one pi bond. Something with a triple bond always has one sigma bond and two pi bonds. So remember this. Just recall that always the first bond is sigma, and any additional bonds on top of the first are pi bonds. That's just the rules for this. So the sigma bond, if you'd like to think of it kind of on a macro scale, is kind of like having a direct handshake. And then the pi bond is kind of like a reach around hug, where you kind of reach around and you hug somebody. Recall that a single bond, an atom with a molecule that has a single bond in it, has a certain distance. If it changes to a double bond, it's actually the atoms get closer together, slightly closer together. And so that is why, is because of this closer overlap of these electrons. And so here's a figure showing actually all the bonding that can occur. If you have a single bond, you have this direct overlap. If you have a double bond, you have this direct overlap, and then the pi bond above and below. So here's your sigma bond, here's your pi bond. If you have a triple bond, you have a sigma bond here, a pi bond here, and then also a pi bond coming out into and out of the board. Again, it's hard to show in 2 dimensions, but that is where all of those extra bondings occur.